Okay, so in this video, we're going to talk about absolute value equations. So remember that there is a process, and that process says that we isolate, so get the absolute value on a side by itself. We make our two cases, the one positive, the one negative. Then we solve each of those equations, and then last, please always check your answers because we can get those extraneous solutions, okay? So first of all, we need to isolate the absolute value because it's not isolated in this problem. So on both sides, I'm going to add 7. Now you can multiply by -4, but students oftentimes just multiply the fraction and then the answer, but you would also have to multiply the -7. So I would suggest do your add subtract first and then come back and either multiply or divide depending on the problem. Okay, so this is going to give me the absolute value of 6 minus 2m over -4 is equal to -12. Now I can multiply by -4 on both sides, and that's going to give me the absolute value of 6 minus 2m is equal to 48. So two negatives make a positive. I have positive 48, so this definitely has the option of having a solution, so it's definitely not a no solution. Even though the original problem is set to a negative, remember we can't determine if it's a no solution based on being equal to a negative unless we have isolated the absolute value. Okay, so then at this point we can make our two cases. So we have what we see, the positive case. So what is inside here can be equal to 48, or what is inside the absolute value can be equal to -48, and that's where the negative case comes from. It's also why we can drop the absolute value. So remember that if you put absolute value marks here that it's equal to a negative, you've just created a mathematically incorrect statement. So be super cautious. So I'm going to subtract 6 on both sides. I get -2m is equal to 42. Divide by -2, and I get m is equal to -21. On the other side, same thing, except my answer is a little bit different because it's a -48. So I have -54 divided by -2. So I have m is equal to a positive 27. So if we want to check these answers, remember that we plug it into the original and make sure that both sides are equal to each other. So I have the absolute value of 6 minus 2 times -21 all over -4 minus 7, and I need that to equal that -19. So I have the absolute value of 6 plus 42 over -4 minus 7. So the absolute value of 48 is 48 divided by 4 minus 7. So that would be -12 minus 7, which is -19. And you would do the same thing with positive 27. So the absolute value of 6 minus 2 times 27 all over -4 minus 7 has to equal -19. It's absolute value of 6 minus, so this would be 54 over -4 minus 7. So then that would be -48, and the absolute value of -48 is positive 48 divided by -4 minus 7. And if you notice here and here we have the same statement, it's actually going to work out the same way. So -12 and a -7 equals -19. So that's a check. So they are both solutions. Okay. So let's look at the next problem. So same thing, I need to isolate my absolute value first. So I'm going to subtract 3. So please remember that this is not adding 3 because what's in front of the 3 is a positive. This is subtraction happening between these, but the negative or the subtraction is going with the absolute value, not the 3. So this will be a negative 54 is equal to the opposite of 6 minus 12r. So my absolute value is not isolated because I have this negative out front. So I need to divide both sides by a negative 1. That gives me that positive 54 is equal to the absolute value of 6 minus 12r. Now I have a statement that I'm ready to break apart. So I have the positive case, 54 is equal to 6 minus 12r. And then I have the negative case, negative 54 is equal to 6 minus 12r. So subtract 6 on both sides. And I have negative 12r is equal to 48. Oh, from r. And then solve for r, so divide by negative 12. So r is equal to a negative 4. And on the right hand side, subtract 6. And negative 54 and negative 6 make negative 60. Divide by negative 12. And we have that r is equal to 5. Okay, we check exactly the same way. So if I want to check negative 4, I need it to be equal to negative 51. So I have 3 minus 6 minus 12 times negative 4. So 3 minus 6 plus 48. 3 minus the absolute value of 54. So 3 minus 54, which is negative 51. So that checks. And then to check 5, you do the same thing. So I have 3 minus 6 minus 12 times 5. 3 minus 6 minus 60. And then we have 3 minus the absolute value of negative 54. The absolute value of negative 54 is positive, and then we get 51, negative 51, which is a check. So they are both solutions to our problem. Okay. So we have now the other cases that we worked on in class, which was where we have a variable on both sides. This one is a little different because I still need to isolate my absolute value. So that has to be the first thing that I do. So I'm going to add 5n to both sides. So I have the absolute value of 8 minus 2n is equal to 6n plus 2. Now that I have my absolute value isolated, I can do my two cases. So I have exactly what I see. So 8 minus 2n is equal to 6n plus 2. And then the opposite of what I see. Remember, we just take the negative. So the negative or opposite of 6n is 6n. The opposite of plus 2 is negative 2. Negative 6n, sorry. And then negative 2. So then now I just solve those two equations. So I'm going to add 2n. Definitely not the only thing you could have done. So I have 8 is equal to 8n plus 2. So I'm going to subtract 2 on both sides. I get 6 is equal to 8n, divide by 8, and reducing by a factor of 2, I get 3 over 4 is equal to n. So same thing on the right hand side. I'm going to add 6n this time. I just like to keep my variable positive. It doesn't matter what you do. So I have 8 plus 4n is equal to negative 2. So I'm going to subtract 8. So I have 4n is equal to negative 10. Divide by 4 and reduce by a factor of 2. Negative 5 over 2. Okay, so these are a little bit different because you're going to have to plug into both sides of the equation to make sure they match. So we'll go with negative 5 over 2 first. So I have 8 minus 2 times negative 5 over 2. Absolute value minus 5 times 5 over 2 has to equal, I ran out of room, negative 5 over 2 plus 2. So I have 8 minus, it's going to be plus, two negatives make a positive, 5 minus 25 over 2 is equal to So make this a common denominator. So 2 is equivalent to 4 over 2. So a negative 5 over 2 plus 4 over 2 is a negative 1/2. So 8 plus 5 is 13 minus 25 over 2 is equal to negative 1/2. So again, we need to make this a 2. So that would be a 26. So 26 minus 25 over 2, 26 over 2 minus 25 over 2 is a positive 1 over 2, which is not equal to a negative 1 over 2. Oh, I made a mistake. This should have been a negative 5 over 2, guys. So that would have been positive, that would have been positive. Sorry. And then we have, which still does not make it equal, 26 plus 25 over 2, left like 51 over 2, which is not even close, right? Okay, so let's look at 3 over 4. So we have the absolute value of 8 minus 2 times 3 over 4 minus 5 times 3 over 4 has to equal 3 over 4 plus 2. So that gives me 8 minus 6 over 4 minus 15 over 4 is equal to, and we'll make this a 4, which makes this an 8. So 8 over 4 plus 3 over 4 is 11 over 4. And then we have here, I need to make this a 4. And that'd be, sorry, 32. Let me, 32, how about that? Over 4. So 32 over 4 minus 6 over 4 is 26 over 4. Positive, and the absolute value of positive is positive. Minus 15 over 4 equals 11 over 4. And 26 minus 15 is 11 over 4 equals 11 over 4. So this one actually checks out as a solution, but the other one does not. So this is a one solution problem. Even though we had two answers, negative 5 over 2 was extraneous. Okay? So let's look at the last problem. So this one is already isolated on one side. So we're ready to set up our two equations. So exactly what I see. And the other one is the opposite. So remember, at no point in time have we changed what's in the absolute value. The opposite of a negative 4 is 4w is a positive. The opposite of a negative 2 is a positive 2. So then we solve. Lots of ways you can do this. I'm going to choose to add 4w. So I have negative 2 is equal to 10w plus 20. So I'm going to subtract 20. So I get negative 22 is equal to 10w, divide by 10, and we get w is equal to, both of those are reduced by a factor of 2. So I have negative 11 over 5. On the right-hand side, I'm going to start a little bit differently. I'm going to subtract 4w. So not negative 2, but 2 is equal to 2w plus 20. So subtract 20. And you get 18 is equal to 2w. Divide by 2, and you get 9 is equal to w. Okay, so then we need to check both solutions. So I have a negative 4w. Oh, a negative, we're going to check 9 first. minus 2 is equal to the absolute value of 6 times 9 plus 20. So negative 4 times 9 is negative 36 minus 2. And 9 times 6 is 54 plus 20. So negative 36 minus 2 is a negative 38. You could pretty much stop there because can the absolute value equal a negative? No, there's no way. So we'll come over here and we will check negative 11 over 5. So I have negative 4 times a negative 11 over 5 minus 2 is equal to the absolute value of 6 times negative 11 over 5 plus 20. So this two negatives make a positive, so 44 over 5 minus 2 is equal to the absolute value, negative 66 over 5 plus 20. So I need to make that 2 have a denominator of 5. So that'll give me 10 over 5. So 44 minus 10 is 34 over 5 is equal to, and then I need to do the same thing on this side. So this one needs to be a 5. So that means that'll be 100 over 5. So 100 minus 66 is 34 over 5. And the absolute value of 34 over 5 is 34 over 5. So again, we had a 1 solution. So the 9 did not work out, but the negative 11 over 5 did.